Our AI can now use the perception system to find the player and move towards them. But what if we wanted to make something more complex? Something that required taking multiple environmental factors into account. For example, what if we wanted our AI to move towards the player as before, but then attempt to hide by ensuring there was a solid object between them and their target? For more complex examples such as this, we will need to use the environment query system. We'll start with something simpler by creating another object that is desirable to the AI, a food source actor, and placing them around the level. We will then enable the EQS system and create an EQS query to help the AI locate the food sources within the level. Let's start by creating the new food source actor. Create a new folder within the Blueprints folder in the content browser and call it EQS. Open this folder, then right-click in the content browser, select Blueprint class, and then select Actor. Name this new actor Food Source. Double-click on the food source to open the Blueprint editor. Move over to the Components panel on the left-hand side and press the Add Component button. Select Cube to add a cube component to the blueprint. With the cube component selected in the Components panel, move over to the Details panel and locate the Collision rollout. In the Collision rollout, move down to the Collisions preset drop-down and change it from the default to No Collision. This is done so that the object and its collision will not interfere with navmesh generation and thus AI movement. The next thing we need to do is set the cube location to Z plus 70 relative to the scene root. This will make it easier to drop it directly onto the floor within our level. With that change completed, we can compile and save the blueprint before closing the blueprint editor. All we need to do now is position a few food source actors within our level. We can do this by dragging them from the content browser directly into the viewport. Next, press P on the keyboard to activate the navmesh debug and confirm that navmesh is not being cut out around them. We can see that this object is having no influence on the navmesh whatsoever, which is exactly what we want. In order to create our first EQS query, we will first have to enable the EQS system. EQS is still considered experimental within Unreal Engine and is not enabled by default. In order to enable it, go to Edit, Editor Preferences, and then in the menu on the left-hand side, locate General, Experimental, and then locate the AI rollout on the right-hand side. Within the AI rollout, enable Environment Querying System. You can then close the Editor Preferences window. Now, we will be able to create our EQS query. Open the EQS folder in the content browser that we created earlier, and then right-click and select Artificial Intelligence Environment Query. Name this new asset EQS underscore find closest food source. Double-click on the asset to open the query editor. Drag down from the root node, and in the Generators rollout, select Actors of Class. Move over to the Details panel and the Generator rollout. First, we'll specify which actor this query is looking for. In the Search Actor class, click the drop-down and locate our food source actor. Uncheck the Generate Only Actors in Radius option. We're doing this because we have no reason to limit our search results to a particular radius. Our example level is so small that it's fine for the AI to find food anywhere that they exist in the level. In a larger level, or with a more complicated AI system, it would be sensible to limit this to a radius. This radius will be specified in the search radius options below. It's important to note that the center point of this particular generator is something called nQueryContext_Querier. This rather long name refers to what is actually making the query. In this case, it will be the AI character itself. Now we have created our first generator. However, we need to add a test to refine the results. Currently, this generator will return every food source in the level, but we only want the closest one. Right-click on the generator, go to Add Test, and then select Distance. Left-click to select the distance modifier. Move over to the Details panel and look in the first section, the Test Rollout. Look at the test purpose. We want to set the test purpose to score only, and we want to set the scoring factor to -1. Note if we look at our distance test in the query editor, we can now see that it says prefer lesser, i.e. prefer a lesser distance. This means the various food actors will be scored on how close they are to the querier, which will be the AI. and the preferred values will be lesser or smaller distances. At this stage, that's all we need to do for our first query. We can save it and then close the window. Now that we have created our EQS query, it's time to utilize the new functionality from within the behavior tree. We will start by creating a dedicated Blackboard key for the closest food source. Later, we'll use this key to drive decorators to help differentiate between seeing the player, chasing the player, and searching for food. Begin by opening the behavior tree from the content browser. Open the Blackboard panel by selecting it from the top right. In the Blackboard panel on the left-hand side, select the New Key button and choose Object. Name this object Target Food Source. Move over to the Blackboard Details panel on the right-hand side, and in the key rollout, expand the key type rollout. Change the base class from Object to our food source actor. Now we can return to the behavior tree by selecting it in the top right-hand corner. We want to create a new sequence that's positioned between the chase player and random wander sequences. This will create a natural priority for the different sequences. Chase the player if we can see them, search for food if we can't, and finally, randomly wander if there's no food in the level. Name the newly created sequence Find Food. Drag out from the Find Food sequence and find the Run EQS query node. Move over to the Details panel in the right-hand side, and in the EQS rollout, expand the EQS request rollout. We need to select the query we just created as the query template. Select it from the drop-down. Ensure that the run mode is set to single best item. Remember, we set our query to only score the items. That means it currently returns more than one item. Setting the run mode to single best item will return the highest scoring item, which will be the closest item. Now all we need to do is ensure that this single best item is stored in the correct Blackboard key. Locate the Blackboard key drop-down in the Blackboard rollout, and change this to our newly created target food source. Now our Run EQS query task is complete. It will run our EQS Find Closest Food Source query, and it will store the result in the target food source Blackboard key. The next thing we want the AI to do in this case is move towards that target food source actor. We can do this by using a Move To task. Drag out from the Find Food sequence and locate the Move To task. Move over to the Details panel, and in the Blackboard rollout, change the Blackboard key to Target Food Source. Finally, much like our other sequences, we will add a short wait task to the end of this sequence. This will prevent the AI from rapidly cycling between multiple sequences in a way that will look unnatural and potentially broken. Once again, drag out from the Find Food sequence, and this time locate the wait task. Position it on the right-hand side of the Move To task. Change the wait time in the Details panel from 5 seconds to 1 second. Let's quickly review our new Find Food sequence. The first task is to run an EQS query. It runs our newly created Find Closest Food Source query. This query then returns the closest food source and stores this result in the Target Food Source Blackboard key. Assuming that's successful, the AI will then move towards this target food source. If the move to is successful, the AI will wait 1 second. Now let's review this sequence's place in the larger behavior tree. We can see how the layout of the tree and the existing decorator already takes care of what we need to happen. If the AI is currently at the food source and then the player becomes visible, the target actor Blackboard key will become set. That means the currently running sequence will be aborted as it is lower priority than the chase player sequence. Then the chase player sequence will run, and the AI will begin chasing the player. If the AI subsequently loses the player, the target actor value is no longer set, and that sequence will be aborted. It will then move to the next highest priority sequence, which will be the Find Food sequence. In the event that the Find Closest Food Source EQS query is unable to find a food source, this will fail, and then the rest of the sequence will be aborted. That completes our alterations to the behavior tree for this section, so we can save and close the behavior tree. In this video, we took a high-level look at the environment query system and what we might want to use it for in our project. For example, helping the AI find desirable objects within a level. We then went on to create the blueprint for this object, a food source, before placing several of them in our level. We then enabled EQS from the project settings menu being mindful that it is disabled by default due to its experimental nature. We then created the query itself and configured it to select the closest food source to the AI when used. We then added a new sequence to the behavior tree that utilized this query.